it's important for us to know how to find what we call the inverse of a matrix. Since we're dealing with 2 by 2 matrices, we want to learn how we can find the inverse of a 2 by 2 matrix. Right, if you're given a matrix A with elements A, B, C, D, that's a 2 by 2 matrix. The inverse of A is given as A inverse is equal to 1 over the determinant of A, which in other words is the reciprocal of the determinant of A. This is multiplying, it's a scalar multiplying a transformed matrix A. In this case, we transform matrix A such that A and D will switch positions. So we'll be having D in place of A and A on place of D. And B and C will change signs. So we'll be having minus B minus C right there. So what we will now be having right here is what we call the inverse of our matrix A. So this is what I'm saying. You transform the matrix A such that you interchange the positions of A and D, right? And you change the signs of B and C. So B and C will change signs, right? And once you have transformed the matrix A right here, then you multiply that by the reciprocal of the determinant of A. So we are saying you multiply the new matrix by the reciprocal of the determinant of the matrix. Alright, so whichever one you start with, no problem, but this here is how we find the inverse of a 2 by 2 matrix. Let's have an example. In our example, we want to find the inverse of our matrix M, where M is equal to 4, -2, 3, -1. That's a 2 by 2 matrix. How do we do it? Alright, so we're saying with our matrix M, we first find the determinant of M. So the determinant of M, remember we talked about how we find the determinant of a matrix. We multiply these two elements, 4 times -1, and we subtract that to the product of these two elements, so that's -2 times 3, and we simplify. 4 times -1 is -4, and minus -2 times 3, that's -6, and -4 minus -6, that's -4 plus 6, and this will give us a solution of 2. So that's our answer right there. The determinant of M is equal to 2, right? And for the inverse, we take the reciprocal of 2, so that is 1 over 2, and we multiply that with the new matrix in the transformed matrix M, where we have 4 and -1 switching or interchanging positions, so behaving -1 and 4 there. And for -2, it changes the sign, becomes +2, and for 3, changes the sign, becomes -3, and this becomes the solution. We now have the inverse of our matrix M.